In brief, NASA has 3D printed a rocket engine igniter created from two metal alloys. The method could help cut down cost and manpower required to build rockets. Our collective 3D printing capabilities just got a major upgrade. Working with a commercial vendor, NASA has 3D printed a key part of a rocket using two distinct metal alloys for the first time ever. There have been other rocket components created with 3D printing, but until now, they have all been composed of a single metal. This new capability has the potential to decrease the cost of building rockets, while at the same time making them safer. NASA's team was able to print a rocket engine igniter using the new process. The method, known as automated blown powder laser deposition, allows for a part to be created in a single piece, instead of several pieces which must then be assembled by welding or brazing. The traditional process takes much more time and manpower to complete, which means the new method could cut costs by a third and allow rockets to be built in half the time. When put the test functionality tests, that is the part created with this new process passed. Image credit NASA Ajity Schneider. Safer space travel. Traditional brazing methods melt together two metals using a filler metal. While the process does forge a strong bond, it still creates a seam. Under the highly demanding conditions of space travel, the intense pressures and temperatures pose the risk of cracking, endangering missions and all astronauts and cargo aboard. The new method eliminates that structural weakness, thereby reducing the risk. This technology could have a significant impact on the Space Launch System (SLS), NASA's next-generation launch vehicle meant to help get us to new celestial bodies like asteroids and even Mars. Steve Wofford, manager for the SLS Liquid Engines Office at NASA's Marshall Space Flight Center, said, "In next-generation rocket engines, we aspire to create larger, more complex flight components through 3D printing techniques." SpaceX is also working to make space travel cheaper in a variety of ways, including manufacturing reusable rocket systems. Efforts like these will continue to open up the possibility for space travel, greatly expanding the potential of learning all we can from space.